Hello, thank you for checking out Mr. Ware's videos, and today we're looking at a quick little study guide for quiz 1 out of unit 2. We're going to go over discrete and continuous, write some functions, and some things like that. So let's take a look here at the first few problems here. So the county fair sells rides tickets for $2 each. Jill wants to know how much money she could spend at the fair. The relationship between revenue and number of tickets sold is blank. All right, so we want to know if it's discrete or continuous. So one quick way to figure that out is if it's something you can count versus something you can measure. If it's something you can count, chances are it's discrete. If it's something that you can measure, then it's continuous. Another thing to look at is the actual input, the input value, the independent variable. If you look at that and can see that it's all just straight whole numbers, there's no different measurements for in between the whole numbers, then it's discrete. If there is a different measurement, then it is continuous. So let's take a look here. Here, the input is the revenue is dependent upon the tickets sold. So the tickets sold is the input. That is your independent thing there. So what we want to do is say, okay, can you have partial tickets? No. So since you can't, it is going to be discrete. Let me get this to work. All right, we'll look at another one here. A company is consistently increasing its profit by 5% each year. The relationship between profit and years is blank. So since it's consistently increasing its profit each year, so it's the relationship between profit and years. Years is the independent variable. That's the input. So between year 1 and year 2, or year 2 and year 3, is there anything going on in between that? Excuse me. Is there a different measurement there? So the answer to that is yes. So in this case, it's continuous. Can you count the profit? Yes. But is there something going on in between? Yes. All right, let's take a look at 3 here. Jack's swimming pool can hold 8,500 gallons of water. The pool is being drained at a rate of 500 gallons per hour. The relationship between hours and the amount of water left is what? So it's 500 gallons per hour, right? And the relationship between hours and the amount of water. Okay, so in this case, the input is the hours. All right, so in between the hours, is there different measurements? Yes, so that's going to be continuous. All right, let's take a look at number 4. My sister is rewarded with $1 for behavior on the first day, $2 on the second day, day 2, and $4 on day 3. Okay, so it's 1, 2, and then 4. The pattern of rewarding my sister with dollars continues for each of the 30 days. So the relationship is what? Discrete or continuous. So we're looking at the days, and she collects those dollars at a certain time of day. There's nothing going on in between. So this is going to be discrete. Okay. Heather owns a clothing store and wants to track the amount of money her store has made after selling each item. The table shows the relationship between clothing items sold and profit. So each clothing item is it looks like $15 each. So one item sold $15, 2 items sold $30. So these are items that you can count. There's no in between items here. So in this case, this is going to be discrete. Okay, let's take a look at these next set of problems. Now, for problems 6 through 8, use this situation. A rare collectible coin is increasing in value due to high demand. Its value grows continuously, so that each year the coin's worth is multiplied by a factor of 3. Assume the relationship between years and the value of the coin is continuous. The initial value is 1,000. So they tell you off the top that it's continuous. All right, so that means something's going on in between the inputs. There's a different value in between the whole numbers. Okay, so the question here, the first question is this situation linear or exponential? Okay, so since it increased by a factor of 3, factor lets us know that we're multiplying. So since we're multiplying, it's going to be exponential. All right, next it says, what is the domain for the function that models the relationship between years and coin value? Okay, so we want to know about the domain. The domain is the input. Now, since it says continuous, that's going to eliminate things like integers or any type of whole numbers, natural numbers, whole numbers, because we're going to count the numbers in between. So you're looking for something more like positive, all positive numbers, all real numbers, every single number, right? Now, if we look at all real numbers here, that's a little closer to what we're doing here. But since we're talking about all real numbers, would mean that you can have a negative year. There's no negative year. So we're going to eliminate real numbers and go with all real numbers more than 0. Okay, so basically they say all positive numbers. All right, this next part, same question. They want us to write both the explicit and recursive function. Okay, the explicit and recursive function. So I'm going to start with the recursive. All right, the recursive, we're going to have the initial start point, in this case f of 0, year 0, right? And that's going to equal 1,000. And then f of n, which is the next term, is equal to the previous term, f of n minus 1 times 3. So we're multiplying each term by 3. That's the recursive. All right, next we're going to do f of 0 is equal to 1,000. F of n is equal to f of n minus 1 times 3. That's the recursive. Now we're going to do the explicit. Okay, and since it is explicit, let me make a change here. This shouldn't be -1. This should just be, I'll take that back. All right, -1 is correct on that. That's good. All right, now on this next one, we're not going to have the n minus 1. We're just going to have the n. So we're going to start with f of n is equal to the beginning, which is 1,000. I'm going to multiply that times 3 raised to the number. So instead of doing -1, because it starts with n, or starts with 0, we're just going to have minus, or just have just n. 1,000 times 3 raised to the n. All right, let's take a look at this next one. Okay, there is a discrete relationship between the number of workers and the number of candles made. Use the information to answer questions or problems 9 through 11. So we got the workers, 1 worker, 2 worker, 3 worker, 4 worker, and the candles made 60, 140, 220, 300. So if you look here, that we are adding 80 for every worker. So you're adding 80 for each worker. All right, since we're adding, what would the relationship be? Would it be linear or exponential? All right, since we are adding, it's going to be linear. linear. All right, next, we're going to take a look at the domain. Okay, so looking at the domain, it says, what is the domain for the function that models the relationship between workers and candles made? So what we're asking is, what is the input value? Okay, is there anything going on in between? Are there partial workers? No. So we know that it's going to be discrete. So since it's discrete, we can't use things like the real numbers at all. Since it's not negative, we're going to use integers. Okay, this one's interesting. All whole numbers over 1. So that would be 2, 3, 4, 5, 6. These are the whole numbers over 1. But we start with 1. We got to include 1. So it's not that one. It's going to be all natural numbers. All right, let's take a look at another problem. Oh, actually, there's another part to this one here. Okay, they want us to write the explicit equation. Okay, and I'm going to rewrite the table so you can see it. We got 1, 2, 3, 4. Got the workers and then the candle. And the candle 60, 140, 220, 300. Okay. Alright, so it says write the explicit and recursive. Let's start with the recursive. The recursive, we're going to begin with 60. So it's f of 1 is equal to 60. And we're adding 80. So f of n, the next term, is equal to the previous term plus 80. Alright, now we're going to do the explicit. The explicit, f of n is equal to 60, term we begin with, plus n minus 1, because we start with 1, times 80. Okay, and that is questions all the way up to 11. So this is going to be part 1 of the video. Next, stay tuned for part 2 to go over the rest of this review sheet. But for now, thank you for checking out Mr. Ware's videos. Have a nice day.